In software development, there's this constant push and pull, right? We're in this race to ship cool new features, like yesterday. But at the same time, we've got to make sure everything is locked down and secure. So, how do you do both? How do you move at a breakneck pace without just leaving the front door wide open? Well, let's get into it because the answer is a real game changer for how we build software.
Okay, think about it like this. Imagine you build a massive 100-story skyscraper. The whole thing is done. And then you hire an inspector to check the foundation. It's crazy, right? Finding a crack down there at that point, it would be a total disaster and unbelievably expensive to fix. But honestly, for a long, long time, that's exactly how we handled software security. The data backs this up too. Fixing a bug after something's already out in the wild can cost like 30 times more than catching it back in the design phase. It's just a broken model. It's slow, it's expensive, and it just can't keep up anymore.
So this sets up a huge conflict. On one side, you've got DevOps, which is all about moving fast, iterating, and just getting things done. And on the other side, you had this old school model of security, which was basically a giant stop sign right at the finish line. This final, slow, painful check before you could launch. These two ways of thinking were just destined to crash into each other.
And the answer to that crash? It's a whole new philosophy called DevSecOps. It's both a cultural shift and a technical one. And this image really gets to the heart of it. Instead of security being this thing you bolt on at the very end, you weave it into every single part of the development lifecycle. We're talking from the first line of code, through testing, all the way to deployment. The big idea is that security becomes everyone's job, not just something you toss over the wall to the security team.
Yeah, this lays out the difference super clearly. The old way, security was an afterthought. It slowed everything down and was a huge pain. The new way, DevSecOps, is all about shifting left. And that just means moving security way, way earlier in the process, to the very beginning. So now it's integrated, it's automated, and suddenly everybody on the team has a stake in security from the get-go.
Okay, so you're probably wondering, how in the world do you actually do that? I mean, you can't have a person sitting there reading every single line of code as it's written, right? That would grind everything to a halt. The secret, of course, is automation. We're talking about a special set of tools that act like tireless automated security watchdogs for your code.
And one of the biggest tools in this toolbox is something called SAST. That stands for Static Application Security Testing. The easiest way to think about it is like a spell checker for your code. But instead of typos, it's hunting for security flaws. It digs through the actual source code, looking for sketchy patterns before the program is ever run. We call it a white box approach because, it can see everything inside the box, all the code's guts and wiring.
But how does a tool like that actually spot a problem?
It's not magic. It's actually pretty clever. One of its most powerful tricks is a technique called taint analysis. It's this really cool way of basically becoming a detective, fingerprinting and tracking potentially dangerous data as it travels through your app.
Here's how that detective work plays out. Let's say you type something into a search bar. That's the source of the data. Now, because that input comes from the outside world, the tool can't trust it, so it slaps a label on it, tainted. Then it follows that piece of tainted data on its journey through the code. If that tainted data tries to do something sensitive, what we call a sync, like talking to the database, without first being cleaned up by a sanitizer, bam, the tool throws up a red flag. This is exactly how it can catch nasty stuff like SQL injection attacks, long before they can do any damage.
So on paper, this all sounds perfect, right? We've got the philosophy, DevSecOps, and we've got these automated tools that are supposed to make it all work. But this brings us to the really big question, the million-dollar question, really. How well do these automated watchdogs actually perform out in the wild?
And this is such a crucial point. You see, researchers at Lund University pointed out a big problem. A lot of developers just don't trust the benchmarks for these tools. Why? Because they're often tested on fake, made-up code that you'd never see in a real project. So these researchers decided to get a real answer. They set up a study to test these tools against hundreds of actual confirmed security bugs found in real, popular open-source software. No more fake stuff. And here are the contenders they put to the test. 5 really popular SaaS tools, a mix of open source and commercial ones. And you can see they don't all work the same way. Some of them lean really hard on that taint analysis we were just talking about, while others use simpler pattern matching. The stage was set for a proper, real-world showdown.
So the researchers took nearly 500 known real-world bugs. They had the tools scan the code before the fix was in place, and then they scanned it again after the fix. The goal was simple: could the tools find the bug? And then, could they see that it was gone? Pretty straightforward, right? Well, the results, they were pretty surprising, and maybe not in a good way.
And this chart really tells the story. You can see the tools found a ton of stuff. They generated a huge mountain of alerts. But, and this is the key part, when the researchers sifted through that mountain to find the real problems, all the false alarms, all the noise, they discovered that only a tiny, tiny fraction of those alerts were actually pointing to the real bugs they were looking for.
Okay, so it wasn't all bad news. There were definitely some frontrunners. The study showed that CodeQL and Horisak were the top performers of the group. But, and this is a really big but, being the best here was, well, it was a relative term, because even these top tools had some serious blind spots. And this number right here is the headline. Even one of the best tools they tested, CodeQL, only managed to find about 15% of the real-world vulnerabilities in the test set. Just let that sink in for a second. That means it completely missed 85% of known confirmed security flaws. That's a huge miss.
So what did this study really teach us? Well, a few big things. First, these automated tools, at least right out of the box, miss a lot of real bugs. Second, they're super noisy. They create so many false alarms that developers can get alert fatigue and just start ignoring everything. And third, how you set up the tool makes a massive difference. The default settings often just aren't good enough.
All right, so where does that leave us? Are these tools useless? Is this whole DevSecOps thing a bust? No, not at all. It just means we need to take a step back and look at the bigger picture. We have to remember that a tool is just, well, it's just a tool. It's only one piece of a much, much bigger puzzle. And this image does a great job of showing that bigger puzzle. Yeah, getting the tools to work is one challenge. But real security means you also have to deal with friction between different teams, you have to navigate all these complex rules, and you have to tackle the fact that most developers aren't also security experts.
And that brings us to what I think is the most important takeaway from all of this. Automated tools are absolutely essential. We need them. We couldn't move at the speed we do today without them. But, and here's the key, they are not enough. On their own, they will not make your software secure.
The real foundation of security, it's all about people and process. It's about building a culture where security is everyone's job. It's about constantly training developers so they can spot issues themselves. It's about getting your security, dev, and ops teams to actually talk to each other and work together. And maybe most importantly, it's about having actual human experts in the loop. People who can tune these tools, make sense of the noise, and hunt down the tricky bugs that the machines will always miss.
So what's on the horizon? Well, the Lund University researchers themselves hinted at it. They think that as AI gets more and more advanced, we might see a whole new breed of security tools, smarter ones that can actually learn and adapt. That could be a way to get past the problems we have today. But, we're not quite there yet.
And all this leaves us with a pretty big question to chew on. We depend on these automated watchdogs to protect our digital lives. But as this study clearly shows, right now, they've got a lot more bark than bite. So as AI and automation get smarter, will we ever get to a point where our watchdogs can actually think, where they don't just spot patterns, but truly understand security? The answer to that question is going to shape the future of pretty much all the software we use every single day.